If you are a developer, you know that when a user logs in, they can often see their access token in the browser. That is the bearer token. So here comes a question. What if they use that token to call APIs they are not supposed to access? For example, in a system with students and teachers, students should only be able to view marks, while teachers can update them. But if your backend does not enforce permissions properly, a student could call the update API directly and change the marks. That is a serious vulnerability called broken access control. It happens when users can access resources beyond their role. So in this video, I will show you a practical example of how this issue occurs in poorly designed systems. This is the role management section of an admin panel where all the roles are displayed. In this system, there are two types of roles, that is system roles and custom roles. The intended logic is very simple. If a role is marked as a system role, it should be protected and cannot be deactivated by an admin. But if a role is a custom role, then it can be freely deactivated by an admin. We will examine the system to verify if the access control rules are correctly implemented or if there is any possibility of bypassing them. First, we will test the deactivate option for a custom role. So the status of this role is now inactive. Now in the network tab of DevTools, we can see the request URL here, and it uses a put method to deactivate a role. We can also inspect the payload, which includes fields like role name and an active status flag. From this we can understand that this flag controls whether the role is active or inactive. When we click the deactivate button, this active value is set to false. Now we will be reusing this same put request for a system role and attempt to modify its active status in the same way. For this, we need the role ID of a system role and a valid bearer token. The token can be obtained from the local storage. To get the role ID, we trigger the edit action on a system role and inspect the network tab. When the edit request is made, we can see the API URL containing the role ID of that system role. Now we try sending the same request using that system role ID to check whether proper access control is enforced. In this request, we set the active status to false for the selected system role. The request succeeds, and the UI reflects the system role as inactive. This confirms that the backend is not enforcing proper role-based access control, resulting in a broken access control vulnerability.